Hey guys, welcome to section 5.5 called Performing Function Operations. So our learning target is I can find the sum, difference, product, and quotient of two functions and evaluate given an input value. So we have learned how to add, subtract, multiply, and divide polynomial expressions, and these operations can also be defined for functions. So basically, we just have functions and we're going to add them together, we're going to subtract them, we're going to multiply them, then we're going to divide them, and then we're going to plug an x value in and get an answer. Okay, so in this table called Operations with Functions, let f and g be two functions. A new function can be defined by performing any of the four basic operations on f and g. So as you see, the notation is a bit interesting. For addition, it's written as f plus g in parentheses and then parentheses x. So that's stated f plus g of x. Okay. Now what that means is we're just taking f of x and adding g of x. If we're subtracting, we have f minus g of x. Again, that just means we're subtracting g of x from f of x. If we have multiplication, we have f times g of x. So we're just multiplying the two functions together. And if we have division, it's f over g of x. So we're taking f of x divided by g of x. So just kind of get familiar with that notation. So in the column to the right, we have two functions, f of x equals 5x and g of x equals x plus 2. We're going to do these function operations with these two functions. Before we start, we are going to identify the domain of every result that we do. So down in the bottom in the italics, it says the domain of the sum, that should say difference, product, and quotient functions consists of the x values that are in the domains of both f and g. Additionally, the domain of a quotient does not include x values for which g of x equals 0, because remember, g of x is in the bottom here, and we can't have 0 in the denominator of a fraction. So basically what we do is we find the domain of both functions before we put them together, and then the result would be the x values that they had in common to begin with. Okay, so let's do addition. F of x plus g of x. So if f of x is 5x and g of x is x plus 2, we have 5x plus x plus 2. Pretty simple. So I can combine 5x and x, that's 6x, and then I have plus 2. That is my sum. Now, let's rewind and talk about domain. What these graphs are will help us think about domain. F of x equals 5x is a line with a slope of 5 and a y-intercept of 0. G of x equals x plus 2 is also a line that has a slope of 1 and a y-intercept of 1. If you remember, any polynomial function, which could be a line, a parabola, cubic, has a domain of all real numbers. So both of these are starting with domains of negative infinity to positive infinity, and adding them together does not change that. So the domain is still negative infinity is less than x, which is less than positive infinity. Means we can put any x value in there. So when we subtract, our domain won't change either. We're just going to take 5x minus, now don't forget to use parentheses, x plus 2. So I'll have to distribute that negative. So I'm going to change that to adding the opposite. Plus this is going to be negative and that's going to be negative. So I will have 4x minus 2. And the domain is the same. Negative infinity is less than x, which is less than positive infinity. All right, let's move on to multiplication. When we multiply these two functions, it's going to result in just another polynomial, just of a higher degree. So 5x times x plus 2 gives me 5x squared plus 10x, which is just a quadratic, which is another polynomial with a domain of all real numbers. And finally, when I divide f of x divided by g of x, I'm literally just making it a fraction with f of x on top. So 5x over x plus 2. Now, you cannot reduce this at all. So that would be my final answer. But remember, we cannot have any x values that would make the denominator equal 0. So we need to, our domain is not going to be all real numbers anymore. we know, so from here, we know x plus 2 cannot equal 0. So solving for x, that means x cannot equal negative 2. And that would be my domain for this one. Okay, now we're just going to do example 1, call it a day. Perform the operation with the given functions and identify the domain of the result. Then evaluate for the given x value. Letter A, let f of x equal 3 times the positive square root of x and g of x equal negative 10 times the positive square root of x. We're going to find f plus g of x, and then we're going to evaluate that for x equals 4. So first, let's talk about domain of these two functions. These are square root functions. And remember, we can only take the square root of 0 and positive numbers. So the domain to start with is x values greater than or equal to 0. Okay. Now, when we add f plus g of x, we're going to take 3 rad x plus negative 10 rad x. And so essentially we're taking 3 rad x minus 10 rad x, which gives us negative 7 rad x. Now we haven't done anything else with the radicals, so the domain is still x values greater than or equal to 0. So this is my sum and my domain. The next part says evaluate for x equals 4. So a way to write that is f plus g of 4. So see, I'm putting 4 in the place of where x used to be. And I literally just plug that into my function. Negative 7 times the positive square root of 4, negative 7 times 2, and that's negative 14. So pretty simple. Let's try B. Let f of x equals 3x cubed minus 2x squared plus 5, and g of x equal x cubed minus 3x squared plus 4x minus 2. We're going to find f minus g of x, and then we're going to evaluate for x equals negative 2. Now, both of these functions are polynomial functions. They're both cubics. Remember, polynomial functions all have a domain of all real numbers. So negative infinity is less than x, which is less than positive infinity. So when I subtract these, when I go f minus g of x, I'm going to write 3x cubed minus 2x squared plus 5 minus, in parentheses, x cubed minus 3x squared plus 4x minus 2. I'm going to need to distribute that negative. So this will become a negative x cubed, positive 3x squared, negative 4x, and a positive 2. And I'm going to combine like terms, and that will be my difference. So I have 3x cubed and a negative x cubed gives me 2x cubed. Then I have negative 2x squared and a positive 3x squared. So that just gives me plus 1x squared. Then I have just a plain old negative 4x. I'm going to write that next. And then I have 5 and 2. 5 plus 2 is 7. So this is my difference. This is also a cubic. So the domain is still x is greater than negative infinity but less than positive infinity. And now we're going to evaluate it for x equals negative 2. So f minus g of negative 2. So we're plugging in negative 2 into every x value that we just found in the difference. So 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. All right. So that's 2 times negative 8 plus 4 plus 8 plus 7, which gives me negative 16. Let's see, 4 plus 8 is 12, plus 7 is 19. And negative 16 plus 19 is a positive 3. So that is evaluating for x equals negative 2, putting it into the difference. So here are 2 answers. All right, 2 more. So we just did a sum, we did a difference, now we have a product, and then a quotient. Let f of x equal x squared and g of x equal the positive square root of x. Find f times g of x and evaluate for x equals 9. F of x equals x squared is a parabola. That's a polynomial. We can put any x value we want in there. So the domain is negative infinity to positive infinity. However, g of x is the positive square root of x. That's where x has to be greater than or equal to 0. So this is the first one where they have different domains. And what you have to do is you can only use the x values that they have in common. So basically, you pick the one that is the most restricted. So that would be x is greater than or equal to 0. That's going to be the domain of our product. But let's find our product first. F times g of x. I'm going to take x squared times the square root of x. And you could leave it as x squared times the square root of x. That works out. If you wanted to have fun with rational exponents, you could do that, but we don't need to. So we're going to do that, and our domain is x is greater than or equal to 0. Now we're going to evaluate it for x value of 9. So I'm putting 9 in for x. So I'm taking 9 squared, which is 81, times a positive square root of 9, which is 3. And 81 times 3 is 243. And finally, f of x equals 6x, and g of x equals x to the 3/4. We're going to find f divided by g of x, and then we're going to evaluate it for x equals 16. Ooh, so I have f of x equals 6x. That's just a line. So its domain is all real numbers. Negative infinity to positive infinity. But this g of x is x to the 3/4, and we have to remember that that could also be written as the 4th root of x cubed. So the fact that this is the 4th root means I can't have a negative number under that radical, because remember, we can't take even roots of negative numbers. So this domain is x is greater than or equal to 0. So far I've limited my domain to this, since this is more restricted than my all real numbers for my line. But let's see what we end up with when I divide these. So I have f over g of x. That's going to be 6x over x to the 3/4. Okay, we can simplify this because this is x to the 1st. And remember that we need a common denominator is the same thing as 4/4. And we're going to subtract 3/4 using our quotient property here. So that would just be 6x to the 1/4. All right, so we end up not having it in the denominator, so we don't have to worry about making sure x doesn't equal, or our denominator doesn't equal 0. So my domain is still x is greater than or equal to 0. And then let's plug in 16. So f divided by g of 16 is 6 times 16 to the 1/4. Remember, the 1/4 power is the 4th root. You guys remember that 16 is 2 to the 4th. So that's 6 times 2, and that is 12. All right, guys, I'll see you in class tomorrow.